Hello, this is Singtech Lee, and this is Physics 2212 Lab Report 3. The purpose of the experiment is to observe distance dependence of the magnetic field, and the fundamental principles I use is the Biot-Savart law to calculate the B field and the distance dependence formula of the bar, which is k times r to the power of n. To give you a brief preview of the results I got from the experiment is that the magnetic dipole moment mu is 0.1995. The experiment, I considered the bar magnet as its sole system, and all of the environment surrounding that magnet is its experimental surroundings. For the assumptions I made for the experiment is that there would be uniform magnetization of the magnet, and there would be no temperature effects on the magnet for the calculations and the measurements for the experiment. And for the setup of this experiment, I used a magnetometer, which is the application of the phone, and I set it to make the x-axis to 0, and I measured the distance between the magnet and the phone, the magnetometer, and recorded the y direction of the Earth's magnetic field. And I recorded all of these data on a spreadsheet, and it gave me a calculation of the average B field in the line of best fit, which is y equals minus 4.4121x minus 17035. And the observations I got from the experiment is that when the magnetometer is closer to the magnet, the x component of the magnetic field decreases. And when the magnetometer is farther away from the magnet, the x component of the magnetic field gets closer to 0. And I made some calculations I got from the data. And by using the line of best fit, I got the distance dependence relation n, which is minus 4.412, and I also get the k value, which is e to the power of minus 17035, which results to 3.988 e to the power of minus 8. And by modifying the Biot-Savart's law and the distance dependence formula of the bar, which is k times r to the power of n, I got the magnetic dipole moment, which is mu, resulting to 0.1995. And I also made some computational model to calculate this magnetic dipole moment and visualize some magnetic fields in arrows. This is the lines of code, and this part is the measurements and the constant values for the computational model. And this function dipole B, which takes in a parameter of mu and r, calculates the magnetic field. And these lines of code are for displaying the arrows of the magnetic field, which is on axis, and there's also arrows which is on the perpendicular line, the perpendicular axis. And this final line of code is to visualize the 45 degrees off axis magnetic field. And if I run this code, as you can see, I got a visualization of the arrows of the magnetic field and got a calculation of the B field at the 45 degrees at distance d as the following. And this could be different from my manual calculations due to human error, like measurements or line of the phone magnetometer. And also there could be a possibility that the magnetometer itself is not precise, and there also could be external magnetic fields from Earth that could affect the calculations and the measurements. I'll conclude by answering the what-if questions. For the first what-if questions, I believe that the calculation would not be so accurate, since it would also affect the magnetic field from the Earth. And for the second what-if questions, if there was two magnets, these magnets would act as a single dipole, which is like a single magnet. And this will lead to making the magnitude to be double, but the direction would still remain the same due to the law of superposition. Thank you.